Right. A little slow. Always. Guess we assume it works. Alrighty. So where I left off just a few moments ago is we are build essentially so we have a table, and this table has columns that we can't really, because all of our tables essentially have the same columns. Now, what we are doing in stream is worrying about data over here, where we have a view called base, and it'll convert something like this to something like data. We have system unique things. Now, this base view will actually have other views that we will be utilizing our system. The select view, insert view, update view. Now, each of these views will have triggers on them that will say you cannot red sign, or you cannot update, insert, cannot update, cannot insert, cannot update. So each of these views will have triggers to prevent you from doing stuff. And all of our procedures will only use the synonyms. So this allows us to keep our views on the database that it's supposed to, so we can add our materialize them later. But on the same side, if we do not build synonyms for our base view, and we keep with the practice that all of our code located on one database and it uses our synonyms to communicate, then we are forced to only use these views. So we force any new developer on our system to use views, and these views will not have all of the columns that you may want. Select will have all the columns, insert, some will be removed, update, others will be removed, and delete will only have 2 columns. It's just a recap, basically, what we are focusing on, what I am focusing on in building, and I will have plug. I will have these bundles up and grab if you want to support me or you just want to learn what we're doing, because after this we're going straight into basically pipes, consuming data, more specifically stock data and everything around stocks, including news, prices, etc. So let's continue on this. Earlier, I was setting up the base view. I had to set up a lot of different dataset trees and select one because I don't want data back. And I was able to modify my column names accordingly. Like I was talking about, str name now becomes what it's supposed to be. So now I need to make sure that we are building the data at the same time we are creating our view. I have a I'm going to create another SQL parameter for columns, column list, so it matches our token. Alrighty. Actually, I don't like seeing this multiple times. I'm going to create another data set name. Call it destination, just like this one. Find first one. Go. Same pattern over and over again. Might as well just do it once so the rest of it fills up. So if we ever have to change this, we're not going through all these places just to do it. Alrighty, so if it doesn't exist, in data point select view where the data point name, our modified name, and point data set ID our destination, then we want to insert that record. So the views that we'll be building. Nice simple regex replace for any sort of billing for you. Where we're just replacing a comma with a new line and a comma. So to operating tenant, dataset ID, destination, point type ID, which will be the same because just because we're changing the name and changing the data set it originates from doesn't mean that it's now not going to be a system flag. So we do want to keep it like that. Now we have a data point name that's modified. Don't really have description, key names. Do want to keep the sequence. So want to keep the active flag. Actually, let's do this the right way. Just like we did this. Curse. There it is. That. Is this. And instead of getting this better. Copy that in a moment because we're essentially just down. Go. So we're taking the table and its sequence and anything associated with it, if it's active, trusted or not, we're converting it, at least the name, to our new name and putting it back in under a by type ID, and all other items that are attached to it will remain the same. Continue. However, this just ensures that it exists in our data set and data point tables, but we still need to build our list. Doing this in order, I'm going to say up here, let us initialize list as empty. So you can do it anywhere, right here. I like to use concat instead of plus due to memory. So we need to say if list is empty, do nothing else, add a comma. So let's actually drop this down so it's more readable. So we're going to concatenate the column list, and then if it's empty, we're going to not do anything. But if it's not empty, we're going to add a comma. And this approach allows us to skip trimming off a trailing comma, because the last column, the list, will have a comma in front of it. So it kind of represents how we code down. And then the data point name. Do this. Return character, comma. So data point name as our data point modified should be it. That'll iterate through what we need to. When it's done, we will have a complete list. What I like to see, I have tokens. Go, grab my token. Send. Correct. And set type is the correct. And we might want to reverse this logic. I don't like having these big begin and end statements. We'll probably say if it's not in this list, not in this template list, or not view type thing, that will raise an error, and then we'll continue doing this normal stuff. I just don't like how I thought of it right now. Kind of what I'm stuck with, but doing. I would say select at SQL execute equals place SQL execute this token with correct parameter. Boom. And select execute is base. This is a pattern I use a lot. Even though we're only doing it once, we could technically just update this base statement and move on. But in cases where we're iterating through many objects, it's just nice to keep the same programming pattern. I don't know if we have the name yet. I'll have to check that out. Cute. Data set name, original name, and the column list. SQL list. Thank you, Morgan. What I do is super simple. I think don't think they're complicated. Don't complicate what I do. Super. I'm just writing select statements. Maybe the thought process, how to solve a problem is different, but there is nothing special about what I do. I don't know. Nothing difficult. Just think how things work. Draw a lot. Draw a But thank you very much. Ask questions, man. I will, or woman, my best. It makes really important stuff. Alrighty. So I have a table defined. Bam, here's the table. I don't like how these column names look. Gross, they don't make any sense. If I want to do select, if I want to do create view, the columns as select star from I want to do this. Some random reason that I hate myself and I want to create this view. This will throw me an error that says ambiguous column name, str name, description, like all these because they're all the same. So that is the point. We want to take this standard naming convention and convert it to boom. Convert it to something that makes sense. So I could actually do that statement and not get an ambiguous error. Save this, go back here. We'll run this. Print it. Something is, oh. Boom. Grabbing our raw. There we go. Use the correct data base because that's where group exists. Create, select, ID, and then I don't like. Because that will actually cause us. Cheers. Do it. Data is. You want to become a data architect? Do anything data. Like, holy crap. Tell me what doesn't run off of data. It is probably the easiest career to stand out in because the skill range is people have no idea what's going on. Look at your normal forums to people way deep into the madness and everything in between. The sucky part is that all of these are the same salaries, but the cool part is that the more you dive into it, the more you're noticed. Super easy field because no one knows what you're doing anyways. No one knows what you're talking about half the time. Just that crazy dude that makes crap work. Or do that. Whatever. Work. It's awesome. Alright. So that column changed. Um, simple query, right? Because I don't like that group is the only table that I have this issue in. Crap. Is take it off. This will say right here the group ID tenant. Don't want it to be I also think the biggest thing what I do is the taxonomy, this from class family type, where a lot of people assume that you just make a table, and that's a really common thing. Even with Microsoft, it's got to stop thinking like that. You don't create a people table. You don't create a people table and stick a first name and a last name and all this other stuff in there, because even if you think of third normal form, that doesn't belong to a person. It doesn't identify a person, the attribute of a person. What a lot of people can have my first name, they probably don't, but it's not unique. It's not a code. So this name right here just names a concept that you think is a person. Could be Z5129 for all you care. It doesn't. It's the defining what type of name belongs to a person. First, middle second, middle third, full name, your name, Twitter handle, the handle, whatever. That's where this model really gets its strength from, is because every time someone gets a new piece of information for this people, have to edit this table, which makes DevOps extremely irritated. Version control is a nightmare. So instead of modifying your objects, add data and taking that concept, instead of writing crazy amount of code, let the data work for you more. This is a lot of code, but let the data work for you. All right. Okay. So if this is this is what's giving us our group ID. We'll just do a quick fix. One column. If it helps, I wasn't a college CS kid. I wanted to be a chemist. This is the same thing, but with chemical. I don't know. That group ID tenant, that worked. That's what I wanted. And this probably created its, no, it probably did not create itself. Yep. Let's make it self. And see if it works. Awesome. Oh, let's give it a bigger test run, because why not? Let's create a few hundred views. Select dataset ID. Dataset. Select. Set base ID. Then base ID. Some another awesome piece of control from how this model works is I want the key name to be data. I'll get 4 databases back. Data main, data archive, data snapshot, data history, and the database type ID. In our database type ID tree, where the database realm relational class soft SQL, just in case I'm storing many databases, because I have had made this system build MySQL databases akin to what I have here by executing Python connected to my SQL server. So it's not just meant to store local databases or MySQL databases, but I only want to iterate through the main data sets, which 240 tables, which looks about right. So we need the payload, the response, operating tenant, data set ID, declare. Oh, come on, what I did that. set cursor fast. We can't fast forward because in this editing the dataset table, so we will get an error that says dataset has changed. They're failed or my from the cursor into the stuff in there. Damn it. Going. It out. Remove it. What do you? Code. Boom. 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 That. Say set payload empty object set payload is modify the payload and the data set ID. Case sensitive. Add it. Get something like this. Be able to our payload. It will create a view. Fill up our data point tables. We have 240 views that we can select from. Awesome. Work smarter, not harder. Kind of go through random ones, see if everything looks right. Everything begins with what it's supposed to. Let's look at the more difficult transaction identifiers. Split at RCFTs class realm ID. This is good. That's how I get data point data set ID. Single, that's perfect. All right. And this was due to select the dataset name, dataset type, key name, data key name, data class key name, dataset key name from dataset tables, data type ID, and where the set realm key name is view. Right now, we essentially have 1,400 files and tables and views that were all created by the system. Not create any of the attributes. That is correct. Oh, domains. That is correct. Classes. All right. So it is typing it as we want also, which is really cool because I could say I am correct. Part of, just to explain the system a little more, Sometimes people look for table names, and we will be doing that, and that is okay. But what if you didn't know what the table name was? Someone changed their name because this system is their system now. And we were like, hey, I'm looking for that view. No, it was a base view. Base table. Yep. So it's the class that's base. Family out, we'll say I know is type. Let's say it was a realm or F group. That's what the view is. Awesome. If we wanted the base table, nothing. So our class key name, history table, should change standard into base also. But basically figure out whatever we want from because that would be domain. Awesome. So I'm going to say that this is done and that I don't care about that. I just want to do mains. I know that there are some issues in archive and all that stuff. So told it to build all of these again and to build all of my system tables just by taking off that database. So every single local main database, please rebuild my views. These views. Great. So now to create these four, but it'll be a lot easier because these are definitions. So that means go I have the objects constructors. Oh, there's nothing. Trigger. I have these definitions. Definition type ID, type ID. So we are going to create triggers, views, definition, ID. So how do I want to associate definitions? What am I doing? Work in patterns. I change definition with data point, everything should work. I work in patterns. Stuff, because I just care about the classifications themselves. We'll just look at the text first. So when I look at, we'll just stick with database. Insert, update, delete. So delete's pretty simple. I only want the primary key. So it should be numeric integer system primary key. I want the primary key and the tenant ID. Type. I think this is going to be I think it's going to be a definition of the data point type relationship. So that's what I want in here. In my select, it's going to be pretty easy because I want everything. My insert is a little different. There are not a lot of things that I want to exclude, mainly flags here. And this is specifically because you can't insert a record into the system that's cleaned already. You have to have it in your system in order to clean it. You can't insert a record that has security. You have to give a record security. So it's a thought process. You don't say this already has security on it. It doesn't make sense. How does it have security on it when you don't have an ID for it? It can't have security. It doesn't have an ID. So in our insert, we like to take the out. We also like to remove specific data set number because that is the same for every record all the way down. Don't want to update it. We don't want to insert into it. Want it to remain the same. It's on a default constraint. Don't want to mess with it. So want that. All of our other, so this is an exception list. Call this insert. This is an only list. Call this delete. What else? I think that's it. Let's also do update. Do we not want someone to update? Honestly, the key name, but just the specific data set number. Don't want them to update. Should be 19, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20 columns plus a parent. That's 21 minus 1. Specific data set number. Alrighty. So the other thing we do not want is native SQL stuff. Nothing native SQL should be in our tables. We will need to create a process that lets us know should not exist. Okay. Point family key name to SQL. And no unassigned row. So, kind of learn a little bit about a relationship. I do this a lot, but re-explaining for new people is always a great idea. So I have a relationship table that I will get on the screen that is nothing like normal relationship table. I'll show you what it looks like. I'll explain it real quick because I'm going to have to relate stuff here. A definition to a data point type ID. All right, so here are the columns that I have in my relationship table. This is for any table. Okay, have parent implied, child implied. All right, parent, primary key, and specific dataset number. So this is a table's primary key and that specific dataset number that we're not going to include in our update list. And we have a child version of that. And then a type. In normal database systems, people have a table and they create another table that has a key from previous table and key table because it's just the ID. And when they want to relate a third table to this table, they have to create another one, relate it. But then if they wanted to relate these tables, they would have to create another one, relate it. So you keep creating all these new objects every time you want to define a new relationship. So this table, what it allows you to do is it says, okay, let's consider 5 primary columns. It's parent, child, pair, a type. So what table, what ID, table, what ID. There we go. We can relate any table record to any table record. And if you think about it, because we store tables and relate tables, proceed. You don't have to have parents, just easy parents sometimes, other times it's not. And the type will tell you what it is. Is it a direct relationship or is it a descendant or ancestor relationship? So you only have to run your recursive CTE once and make your system faster. That's how we do it. So we're going to make definitions, I believe, relate to data point types via a specific relationship type. And I have done this in previous videos. Functional relationship tree. This is what we have already. So we do have data point type definition relationships defined. But represent. They are functional. They have a specific system functionality to them. The function is because objects depend on them. All right, defaults, foreign keys, index include, indexes, nullable fields. So the definitions I have, or the relationships I have to definition the data point types are for building my indexes, default values, and nullable fields tells us if we null these or not. This is how simple data can control large swaths of functionality. You don't want to know, you want to define all of these. Come up, write them. Hey, this. Sweet. So I want to create a definition to data point type again, functional, blah, blah, blah. And we are going to make the 2 columns. What is family that we are under? 1008. So to define a completely different type of relationship, go in our relationship type table, get a couple new records. I think we only need 1. Thinking. Yeah, that'll be fine. So this definition data point type is for data point types allowed. View point types. Relationship controls what point types should be allowed in what DML crap. View. Hate when you hold shift and press space and SQL does that. Change that, Microsoft. And we will say this is a view key name. None of these look plural. Should be good enough. So because I'm going to be adding more data point types and all that stuff, I want to create a utility process to handle this on a regular basis and attach this similar to what I have for shrinking databases. For the unit, it takes in a database and it shrinks each of these files. So I want to create another utility procedure that's meant for dataset, view, data point types. Relationship. So this isn't going to have payload. It's specific functionality to make sure these are up to date. So ensures the correct types are associated with definition based schematic. Should be easy. So select star from tree. Say key name. Construct. Boom. Get definition type ID for the incoming group ID, and essentially this plays beginning single quote abs, comma. Let's fill in the end. Wait. So I'm saying, hey, I want this type ID. For testing purposes, I will just say this is a 1 now, and I can come in here, say based on that type ID is delete and definition type ID is type ID. Should give me one record that represents the delete view, another record that represents the select view. So it's the same taxonomy, same classification, but now we have specific things that we can relate to because we want to do the same thing for, try to do this off the top of my head, definition, spell, definition, data point type, it's a functional relationship, objects, what? Thing, bam, wait. Let's see. Sometimes just create one. Other times I'll be more specific. I think in this case I'll be more specific because it'll make, I don't know, guess something. It's definition ID for select. I actually think programming this way helps you better understand where the patterns are. What actually changes get completely different meaning for what you're looking at. Now, insert, data update, select. So now I'll have each of my views, and now I can relate using this relationship type ID. Essentially, say, insert into play, comma, line, and a comma. Okay, I want to create these new relationships. Make sure they're related. So In our function that creates these four additional views, it can just pull from data and say, oh, only in this list, organize it appropriately. Only in this list, organize it appropriately. And we can attach this new utility to something that creates new columns, new data point types to make sure that they are all connected. So we have a couple of exceptions. Select is everything, but overall we don't want this. So comment this out, and we're going to continue to work on the actual want. Select data point type ID, data point data specific from a realm that wasn't unassigned. Gotta be a data point or the family key name equal to native SQL, say, or not. $45. So this would be my select. The relationships for my select. Only list. In the odd case that I have multiple tenant and multiple primary keys, I will say and delete list. Insert list, which accept. Wow, come on, dude. my output. Remember it, I should this back since we're no longer testing, and I will definitely about it. This allows us to keep the same code, and let's say some other companies like, hey, I want to use your system. Like, yeah, you can use side by side my system, not actually my system. I would just give them their specific identifier, their GUID or whatever, and have a web service make sure to convert it into its integer form so they are messing around with their own data. So I can iterate through every table based on the tenant and delete their data when I no longer want them to be part of my system. Or if you think of heuristics, I can create a tenant that's a compilation of all clients in my system and try to match and merge multiple data sources together to find a bigger picture regarding what I'm looking at. Whether it's, I want to create a tenant for Facebook, a tenant for Snapchat, a tenant for stocks, and I find different companies and different people, different news stuff, and I want to create a tenant for everything so I can merge and say, oh, look, these people have the same habits, and create a new person after a profile. Like Target. All right. So I know I have a data set name I want. Definition. Actually, by the extra step. And just because I should do. Cool part about selecting variables like this is one of these is null, the other one will fill in correctly, and the bad part about doing it this way is that if one of these are null, the other one will fill in correctly. So if I get a ID from here, null, it'll keep this ID. Well, it won't have anything, but then it'll both good and bad. But that doesn't matter. Number. Yeah. And you get sponsored, so someone can give me a really awesome mechanical keyboard. Super awesome. Even though mine's pretty cool, it's cheap. Too spicy, too spicy. No, I don't care. I was thinking, I could query these for JSON, create an array, and fill up a temporary table, an at table variable full of these 4 arrays, and then have one cursor. But to be completely honest, I'm creating table variable, which will put pressure on the temp DB, albeit almost nothing. Oh crap. Copy that. So I should have these 3 cursors that I will put some separators so I know what is going on. Some sort of separation. Wait, now all we have to do in here, get the appropriate insert and uncomment this out and basically fill in 90-bit. Want the operating tenant type ID, system relationship type ID. This will be our specific definition ID. Kind of why, do I have 4 parameters or 1? Doesn't really matter. This will be the specific data set number for the definition to let us know that, hey, table it comes from. This will be the data point type ID generated in each of our cursors and the specific data set number for that. Sequence and display order are irrelevant when it comes to this sequence. It doesn't matter what order they are in because that is determined by the data point table. That is the order they will be built in, the same order that they appear in. So now it's really, if not exists, select one from our select where type ID our type ID, primary key parent and the primary key child are equal to their respective items. That good because update it. So in my select cursor, essentially, hey, this doesn't exist for the select definition. Go ahead and insert that for the select definition. It'll iterate through 45 records. Not an issue. Again, okay, for the delete definition, insert definition. Insert to update. Now I could have done this thing Excel and just filled the data in, but that means every time I had to add a new thing, I was going to have to figure out all this crap again and manually enter it in. So this actually allows me to ignore all that, put this on some sort of execution. This anymore. And I'm actually going to execute this right now if I did it completely wrong. Borrow pinned scratch pad awesomeness. Completed successfully. Who knows if it worked? Let's check. Yep. Come on. So it will be mixed in here because the definition ID changes. Leave our definition IDs ones. Definition would be parent, so 39, 40, 41, 42. Parent. Oh, doesn't look like it fired at all. Oh wait, just look at the wrong wrong definitions. Did 35 through 30. These are triggers. Darn it. Darn it. What am I doing? Yeah, we're in there. For all them. Specific to. I'm an idiot. Don't mind me. Wait, so that does its job. Now we can go build all the views because it's super easy. Have a procedure laid out. Standard definition. Going to say we're going to steal some code again because I worry about it. Steal this code. Boom. That will return 4 records. For each of those records, we are going to steal this code. That will store 4. Bam. Some more code. Been a developer for very long. You borrow a lot of code. If you've been a developer for longer than that, you know how bad this is. Not be doing this. This isn't code reuse if I'm taking code. Correct. Want this crap. Alright, get the definition type ID, get the system relationship ID. So if I select the definition ID and definition key name from then select here or tests. Hey, those. Let's go. Say on. Dude, what are you doing? Doing flippy floppy. If I get a table dataset ID, already missed, can build the base view. That will no longer be base. It will be select, insert, update, or delete. It will give me the right dataset type ID for view. I can create. However, if I get a dataset ID in to figure out the base view, those are the columns I want to work with. Do I want to make this translation again? No. Translated that in the base view. So, should get, this is what I want to create. This is the base view. Should match. This is super foldy fold stuff. Let's see if I can draw it. Let's see if it makes more sense if I draw it. Probably not, but due diligence. So I have a data set, realm, class, family, type. For a table, and the don't really matter. For my base view I did earlier today, what it looks like. For these other views, create more, but these will remain the same. Down. Then we have our actual dataset table, group, or database, whatever, from the table, but they also will remain same all the way down. So I'm going to get this ID, figure out what this whole chunk was, base, so I can find out table it belongs to, what data set it belongs to, because those column names are going to be the same for all of these anyway. All these squiggles, they make sense to me somehow. Do, I swear. I swear they do. And that's what we're going to do. We're going to get a dataset ID in parameters. Steal code because we can. Boom. ID. Oh, want that stuff. Oh, and we want that stuff. Want say definition. Say base. Say set ID. one of your triangle type relationships in. That gets a little complicated vision. But if you understand what I did and you're not in this field, you need to be in this field. All right. I send it TBL group, it comes in, it finds all the information needed for TBL group, which is important because we need this stuff. It'll get the database name, which I have not declared yet, so let's just declare that right now. It will get the database name for the current data set that I'm sending it in, because the views will exist in the same area. Awesome, get that. These really don't have a specific order, so I'm going to put them at the very top because need definition types and relationships types for later on where the stuff actually happens. This will be a cursor that I want to create, cursor for each definition. Because for each definition, there's going to be a slight change in the data type. And it doesn't really matter what the source is from, because we have view right here. Could change it to the base. Doesn't really matter. Really need. Yep. Blown. All right. Incoming is a dataset type ID that I'm going to borrow some information from. Convert to view base. This is what got us our base type ID anyways. Here, look at the base type ID. Come back down here, make sure that the key names match. Key names match, I will get my base ID. I've shown that while messing around with the querying for base view. So this is my base. This will be what I select from. Also be what I through. But cursor through it. My relationship happens. start splitting this out. Things that don't need to be iterated upon. I need one shot for the base view. Table will not be messed with. Fast forward to go. I don't care about this. Like mentioned there. To do approaches because I have more control than just a simple select into. Alrighty. Never used cursors before. Teach you something. If this fires and it's null, keep the same ID. So we want to make sure that this is null, so it can fire. It can be null. Try to insert something, and it'll say good. Get key name. Boom, boom, cleared. Now I have the dataset type. Now I have to make sure that the dataset type lists. God, I should really do this. Yeah, let me see if I'm mistaken. Yeah, that's what I thought. There's no proper case function. So this is what I'm doing. I'm taking to do. First letter, uppercase, S. The rest of them, lowercase, select. Give me B, BLGRP group, underscore, select. Boom. List. Still. At least we don't have to. Yeah, that would work. Correct. Be subcursor. This is destination. Definition exist. And because we are querying this inside a cursor, again, will contain the previous iteration. Select, it'll insert an ID, hold on to this. Do not want that to happen, therefore, null it out, try to fill it, still null, then we continue, get the next item, not B. Boom. Same code. Instead of using output, because output's a little messy, especially since it only lets you do output to a table variable, might as well just select it again. All right. If select view doesn't exist, go ahead and insert it. But if whatever view doesn't exist, go ahead and insert it and hold on to it. This will be the base that we did the transformation on. Get all the necessary information that we need from this, meaning this. Go. So for instead of the data set, it will be the base. I'm gonna get. Let's throw this all away. Alright. I have that. That type. Damn it. List. Not modified. Keeping it. Same concatenation, kind of. Without that. Of course. Oh, yeah. I know what it's from. It's really appropriate. Follow it down. Gotta make sure. Side definition. Begin side definition. So I should have a fetch and then I should have end fetch end. End fetch end for the definition. Boom. Alrighty. Finally, this. And oh wait, that. Like I was saying when I was constructing this, why I use this technique. Did I not copy it again? Why I use this technique? Because base never changes, overrides the execute, execute gets replaced, and then gets ran. Snap. Boom. That's what I was thinking. So now this up. Works, database name. Yes, I might have it. All right. Let's give this a shot. Probably killed it. Up. No problems. This is definition standard and should be from here. Absolutely. Again. Top level item. Writing 10.1. Set. Well, insert, update, select, delete. That's not correct. Oh, damn it. Damn it. Sweet. So delete. This relationship's not attached. That's why I do whatever I wanted. We still need to check. Did what it was supposed to do. Awesome. That was very sure. Gonna take cut because we don't have triggers on here yet. So delete from point where we're gonna delete data points and create them because we messed up and I messed. Bah, bah, bah. I'm so happy I bought a UPS. It was like the 10th time today. Power's flickering because the ice is starting to melt. Yeah, good stuff. So we're in the base and data point type ID is in the new stuff that we just created, the system relationship primary key definition child implied from relationship table where parent so this is what I was talking about. Now we have filtered down our IDs. So at least we know we built the view. At least we know that the data set is, or typing it correctly, going from table to view, back to view again. The thing that did not see when creating proper filtration of columns should be everything should be 2. Bam. And we shouldn't see plan displayed other security archived here. Bam. And I guess shouldn't see specific data set number in this one right here. So that works. So now, oh no, wait, no, saved it, right? Not. Well, I'm going to save it this. Because we're iterating through data sets and the whatchamacallit, the view builder is accessing the dataset table. We have to make it static. The dataset ID from the set table where the dataset base ID and base select base type ID, then free where family is local and type is main only for right now. Guess we should be complete about this. Ask yourself, what are other realms of databases that are not relational? And oh, NoSQL. But also say, oh, about folders. Conceptual data. $25. Names. No V's. Awesome. All right. All right, buddy. Show me potato salad. Oh, what? Oh, damn it. Not as fun anymore. Come on, 1,000 views created in a long time. 18 seconds. 240 times. Select, insert, update, delete. Damn. Sweet. Well, we got a view creator, and I am saving this part. All views. This is pretty good. Yeah. Now we're essentially going to do the same thing. Relationships and what should be, or templates in general. We have to create some functions. I want to make sure I have all these particular functions and some newer ones. We also have to create some procedures. I think I'm going to call it for today. I'm going to see if I can start my car. Ice is gone. But we also want to create these for the RCFT so we can be more dynamic. And I think we're getting really close to starting to mess around with stock APIs and storing all that data. Got a lot of places to store data and to analyze data. Oh crap, the triggers. Triggers. Doesn't. That was a big feat. One day, you create 1,000, 2040 times 5, 1,200. Have a good day, everybody. Thank you very much for watching. Um, Tomorrow I will update this on Coffee if you support me, and to download this beast of a model yourself, it'll cost you. But you can watch my videos and learn how to do it. That won't cost you anything except time. So if you have any questions, make sure you catch me on the live stream, subscribe, follow, and all that. I'm dual streaming to YouTube and Twitch right now. Stream. But if you have any questions, because broke and want me to answer them, definitely ask them. Questions on general, definitely ask them because this is what I do for a living. It's awesome. I love it. Happy Valentine's Day, everybody. My wife is mad at me, but it's not. Not because it's out. Either ways, have a good one. I will see you next time. Bye.